Hello everyone, today we are going to solve partition label LeetCode medium level problem. So in this problem we are given a string and we have to do partition of this string as many part as we can, such that each letter in this part have at most in one part. Okay, what it means is if we have this string, so we have to divide this string in such a way such that if one letter is present in a one part, then it can't be in any other part. Okay, so let's understand with this example. So in this string we part in the three way, this and this. So here in this string we have the letter A, B, C, and yeah, A, B, C. So A can't be in this part or this part. B, C should not be there. Okay, so we have to do such a partition, and such a way we have to partition in such a way such that if we concatenate this, so it should return the original array. Okay, that means if we join this, so it will become our original string. Okay, now we can't do something like this because in this case we can have this many solutions. So we want to maximize the partition. Okay, so let's understand how we can do this problem. So how we are going to do this problem? We are going to pass this string twice. In the first pass, we are maintaining one array where we store the last occurrence of each letter. Okay, for simplicity, I have done already calculated this last occurrence. So the last occurrence of A in this string is at the 8th position, at the 8th index. Okay, and the last occurrence of B is 5 and so on. We have calculated the last occurrence of each letter. Now in the second pass, what we are going to see, we are going to see if if our pointer cross the last occurrence of that letter, then we have reached that part. Okay, let's understand with an go through. We have taking two variable last index. Let's initialize with -1, and we have our starting index which is initialized with 0. And what is this last index and starting index? This is are the pointers last index of an part. So this is the starting index of an part and this is the last index of an part. Okay, so how we are going to do? Let's pass from this. So last occurrence of A is 8. So we are going to update last index of this is 8. That means for our first part, the last index will be 8. Okay. Then we are going to see B, increase our pointer B, and we are saying the last occurrence of 5 is this. So we will going to update last occurrence if our last occurrence is more than last index. Okay, in that case we are going to update this. So right now B last occurrence is 5, we are not going to update. Then A, and as soon as we reach this A, so our pointer will be at 8th position. So whenever our pointer points to the last index, we got our first part, we got our one part. So what we have to do is we have to just push this length. We have to just push this length. So how we are going to push? We are going to say result dot push last index minus starting index plus 1. Okay, and now we have to start with our new part. So our new part will be start from here, and for that purpose we need to update our starting index. So what will the starting index? Starting index will be I plus 1. Okay, this our earlier last index plus 1. This will be our the starting index of the next part. So we are going to update it. Then the last occurrence of B is 14. So we will update it to 14. Then we are increasing our pointer to E. Last occurrence is 15. Then increase 15. Then F last occurrence 11. So we will not update. Then again E 15 we will not update. Then G our 13 not updating, D, then E. We reach to E, so our I is 15 and our last index is 15. That means we are reaching the end of our second pass. So we will going to update this last index minus this. So our result will be an array. First we are going to update 8 minus 0 plus 1, that is 9. Then we have update 2. Now we have 15 minus our starting index was 9. So 15 minus 9, 15 minus 9 plus 1, 15 minus 9 6 plus 1 7. And now we are going to update starting index will be 15 plus 1 16. And now starting from H, last occurrence of H is 19. Last occurrence of I is I 22, J 23, and then H 19 we are not updating. K, our last occurrence of K is 20, so we don't need to update. L, I, J. So we as soon as we reach to 23, I equals to 23. This will be our the last index, and as soon as last index equals to our pointer, we are going to update this. So last index is 23, starting index is 16 plus 1, 23 minus 16 plus 1 will be 8. So this will be our answer. We need to return this. Okay, I hope you understand this. Let's see the code for more information. So we are going to declare one answer, that is a vector, and one vector to calculate the last occurrence, which is like I have calculated 26 and 0. Initializing with 0, and then we are going to update it the last occurrence of all letters. Then we are taking two variable, last index, which is the last index of any part, and the starting index is the starting index of any part. And then we are going to update last index if last index is if last occurrence is greater than last index. Then if we reach to the last index of an part, then we are going to push that length into our answer and updating our starting index to the last index plus 1 or I plus 1. Okay, and then we are going to return this answer. Then what is the time complexity of this solution is? So the time complexity will be O of n, and the space complexity is O of 1, because we are using only the constant space. I hope you understand this problem. If do you have any doubts, so you can ping me in the comment section. Thank you for watching.